We've all seen the pictures of our blue marble floating in space, but what if the Earth is actually smaller or flatter than we are constantly told? Skeptics often suggest that the curvature is either exaggerated or simply doesn't exist in the way mainstream science describes it. Today, we're going to dive into the evidence that confirms our planet's true shape, starting with measurements from orbit. Satellites, which are essential for modern communication, must constantly account for Earth's predictable curvature to maintain their orbits. If the Earth were a significantly smaller ball, the orbital mechanics for these instruments would break down almost immediately. Moreover, direct photographic evidence from multiple space agencies consistently shows a spherical shape. Now let's consider the seemingly simple act of circumnavigating the globe. If you travel consistently in one direction, say due east, you will eventually return to your starting point without ever hitting an edge. This feat is only possible because the surface you are traveling upon is continuous and round. The existence of time zones further reinforces this. The sun sets and rises sequentially across the world. On a flat plane, the sun would illuminate the entire surface simultaneously, though perhaps at different intensities. Next up is the global positioning system, which is a daily miracle we often take for granted. GPS relies on signals from at least 4 satellites, using a process called trilateration to pinpoint your location. The underlying mathematical models for trilateration, especially factoring in relativity, fundamentally assume a curved planetary body. If Earth were significantly less curved, the required timing adjustments for these signals would be drastically different. Engineers would be unable to achieve the meter-level accuracy we experience every single day. This leads us to the fascinating evidence provided by gravity itself. Gravity dictates that mass pulls everything towards its center of mass, which naturally forms a sphere. While the Earth is not a perfect sphere, it bulges slightly at the equator. The general pull is directed inward toward a central point. Gravimeters placed across the planet measure slight variations, but the overall force vector confirms the spheroid shape. These localized gravity anomalies are accounted for within the standard geodetic models used by every major government. If the Earth was fundamentally smaller, the measured gravitational constant would yield inconsistent results globally. Imagine standing on a very small ball. The horizon would drop away far more rapidly than we observe. Long-distance surveying relies on precise calculations that account for the expected drop over distance due to curvature. These consistent measurements across centuries prove the Earth maintains a consistent, large spherical geometry. The idea of a smaller or significantly less curved Earth simply cannot reconcile with the integrated global systems we use daily. From the perfect arcs of satellite paths to the very timing of your phone's GPS lock, the sphere model is proven. Every observation, from a ship disappearing hull first over the horizon to deep space photography, confirms the established science. The Earth is undeniably a large, spinning globe, a fact supported by an interconnected web of physics and engineering.